Okay, I'm going to share my screen.
Go ahead.
And so it's gonna be the whole screen. So what I did is I worked on a little app which allows to estimate uncertainties for the triangulation of two cameras. And I'm just gonna show it, and I hope it's working now while I'm sharing the screen, but it looks good so far, I guess. And I made a change compared to our last meeting in the code. In our last meeting, I had a uniform error distribution, and I changed that now to a Gaussian
Jannik, sorry.
error distribution.
Are you
Yes.
sharing something with us?
I thought I do, but is anyone seeing my screen?
Yes.
We see you on Discord.
Okay, but you don't see the app?
No.
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 Oh, okay. Let me try again.
And we have an echo.
Yes.
Okay.
Yeah,
Let me
because
check one more thing.
he shared the same screen.
Okay, let me try to share again. Sorry for that.
Hey, Lionel.
Hey,
Okay. Yeah, I'm sorry. I pressed the wrong button.
No
Now
worries.
you should see the
Yes.
code
Yes.
here and also the app.
Yeah.
Yes.
And okay. So the change that I made compared to last time is that I changed the a uniform error distribution into a Gaussian error distribution. That is this stuff here. And it looks more intuitive now. And we can check that. So when I start sliding, in the beginning you don't see anything, but when I start the slider here, you see now how the data looks like. And it's also showing the triangle in 3D space. So in the bottom here, you have basically the fisheye camera and the PTF, or you could also think of it as just two cameras that have both information on the azimuth, so the horizontal angle to the object, and also the elevation angle. And what you can do now is you can change the position of the object, and you can see how the uncertainty range depends on the distance or the height of the object. So basically, when I increase the height, it's the uncertainty is also increasing. So you can check it up to 10,000 meters here right now. And it also displays the sort of real distance, let's say, that is based on the calculation here. That is the distance between the fisheye object and the fisheye lens and the object. And you can also test what kind of an impact the uncertainty has in the estimation of the elevation angle, for example. I just bring it down here again to, let's say, 1,700 meters or so. Then we have an uncertainty range here of 140 meters, let's say. So when you would do the calculation, you might end up with readings between 1,220 meters as a distance or up to 1,840 meters distance here. And when we increase the uncertainty of the angles, then you can see that it should increase. So this uncertainty is increasing, and you can, I think, so that's nice for me. You can build up some intuition how the dependencies are between for the angles here when you change the uncertainty, and how important it is to have like a a good estimation of these angles. So when you see, like when you have an uncertainty that's increasing further, then also the distributions look a little bit stranger, but it's also, you can see how much it's increasing. So now we have an uncertainty of 0.4 degrees instead of in the beginning 0.02. That's roughly based on what Christian said last time, for the uncertainties that we can expect. And so here we see how important that is to actually have really good estimates of these angles. And I think it might not be as trivial as we maybe think, because of the simple tracker. So the simple tracker, I mean, it's a really good product. There's no question about that. But the box is a little bit jittery. So, you know, to really have a very so it's not always exactly centered on the object. That's at least my feeling. So you have a little bit of an uncertainty only because of that, for example. When you say we make the estimation of the elevation and azimuth based on the bounding box, and we always choose the middle of it, that might not always be the middle of the object itself. So we might make a little mistake because of that, and so yeah, we just have to check it out. And yeah, that's basically it. So you can change your different parameters also, the X position and the Y position. And you can also change the distance of the camera, two cameras, and you see it should go down a little bit, but it's surprisingly not as much as I thought. But when you decrease it, at some point you see that it should increase quite a bit. So yeah, so that's just an invitation to play around with it, and again, to everyone also to double check the code, basically. Yeah, I guess that was everything that I wanted to show here.
Okay.
Yeah, that really is nice. Yeah, I love it. It's
Thanks.
yeah, it shows where the problems are and what we have to understand from that matter. So that basically, if we say, okay, we have, let's say, every two stations pointing up with a distance of, let's say, 30 kilometers, it gives us much better readings, and only
Probably.
40 centimeters between Old-School Chem and PTF is not enough.
Yeah. Probably, but it also shows that at least you can get some estimates. I mean, it's not perfect, of course. That's what we expected, but yeah, at least
we expected that the accuracy is not great, but we with 40 centimeters in distance, we already get some readings, and the estimation is not that far off.
Okay.
Can we do an example, Jannik? Can you set the distance back to 0.4? Is that possible?
Yeah,
Or
I can try.
Or restart the app. Ah, perfect.
Okay, now it's
okay. So, and can you set the? By the way, object height is the elevation of not elevation, is the altimeter, so the height where the object is situated from ground.
Yes.
The z-axis, let's say.
Yes.
Yes.
It's the z-axis. Yeah.
Okay. Can you put that just on 1000, for example? Just make some steps. Start with the 1000, for example. Something around the 1000. Yeah. Yeah, perfect.
Yep.
So the uncertainty is 81 meters.
Yeah, it should be around that. So it's always drawing basically random values out of a Gaussian distribution, and it changes a little bit based on that, what kind of values are generated here. But yeah, roughly.
Yeah.
Yeah.
can you now set the object height, let's say, to 5,000?
Okay.
So your range goes to 10,000 something. Yeah.
Okay.
So it's 764. Okay, this is non-linear. Can you, the last one on the total on the right, 10,000 I think it is, totally to the right. Yes. And it's 2,160. It's almost, it goes from around 8% down to 5%. The uncertainty of distance, the distance. So when the distance, the height, only the height, the distance is something different.
Yeah.
The height.
That's here.
But with the height goes the, there's it. Oh, sorry, I didn't see that. Oh, there it is.
But I'm I'm surprised. I mean, that's why I say double check my calculations. Because I started doing that last weekend and it was in the heat and my brain was melting basically. So yeah, that there's something.
Can you please
is it?
bring back the object height to 5,000 so that I can read because I didn't read it just around. Perfect. 4,780.
So I'm curious to know the uncertainty range. How will it translate to what we can see with the telescope? Because if we can see the entire uncertainty range, that means that we can still have a log, which is good enough. Oh, actually, no. That means that you see both of them anyway. Never mind. Forget about it. So.
Okay. Yeah, I have to double check my own code again. I think there's still a bug in there. But in any case, yeah, I'm going to keep working on that. Next weekend I'm traveling, but the weekend after that I'm going to continue working on this. And yeah.
Can you do me a last favor, Jannik, before you stop that? Can you go back to 1,000 in height?
Okay.
Yeah, that's okay. That's around 1,000. Okay. Just finding out how the digression is. Interesting. So it goes from around 8% to 16% to 22%. Of course, it needs to be bigger. The cone is opening up. The bigger the distance, the bigger the inaccuracy is, of course. Can you now go back and change the distance of the cameras, let's say, to 0.8 instead of 0.4?
Yeah. So that's roughly, yeah.
That's 43. That's 43 on this. Well, can you go back to 5,000 on the object height?
Okay.
Yeah. 485. And the last is on to the right, to the 10,000. And then I'm done. 1,627. Is 17. Just by doubling the baseline, we gain on the biggest distance 5%. And on the on the smallest we gained 4%. So it's about, really, it goes linear. So increasing the baseline goes linear with the accuracy becoming better.
Yeah.
So increasing the baseline is directly linear, but yeah.
Because we have a triangle, and it's both of the calculation goes not for the what's that called? It goes for the height, for the middle line in that triangle, the height line, and therefore you get not that much accuracy gain, and it is too you can divide the triangle into two other triangles that are used with Pythagoras. And that's
we can
why
also look at the slides. This one here.
Yeah.
Maybe.
If A1 is equally to AB, and DZ is, let's say, 10,000, and it's dividing both triangulars in equal triangulars, yeah, it's linear. Because dx and c is equal to each other.
Yeah.
The x and c is equal to each other by x?
dx and c.
So dx is the
one.
baseline. Okay. You mean dx and c, okay, of the baseline.
Yeah.
So they sum up
Yes.
to the baseline. Okay, good. Yeah. So when it's totally in the middle, yeah.
So then basically what you're saying is this in this case that you describe, this triangle is the same as this triangle. Right? Okay.
And therefore it's linear because you have symmetry.
Yeah, because
They're symmetrical to each
in
other.
the bigger triangle. So what you can say is that an object in distance, I say it now in height in meters, at 1,000 meter, 5,000 meter, and 10,000 meter, gives an accuracy with our baseline of 8%, 16%, and 22% inaccuracy. And when we double the baseline, we just drop that by 50%. Okay, so
by 5%.
By 50% of itself. So 8% will cut down to 4%,
okay, yeah.
16 will go back to 10% in this case, and 22 will go back to 17. So it's not exactly 50%. Yeah, it's a little bit more. So yes.
Yeah, I mean, so these are the kinds of experiments one can do, right? So I think it's helpful, and everyone is invited to do that. I just updated the code here, so you can just download it here. This one, that's the app.
It's still on your GitHub.
This is on my GitHub right now because I didn't know where to put it else. Where else to put it?
Ido, shall we fork that?
Yes.
Long thinking. Yes.
Well, right now you have it on your own repository, if I remember correctly, right?
That's my own repository. Yeah.
Yeah. So what you can do, you can actually fork our repository, the main one, okay, and put this under a directory under research.
Okay.
I
don't have much experience with GitHub because for my own work I use Bitbucket. So, but I can try. I hope I don't break anything.
Okay, so let me know like times that you have this week to work on it, and I can guide you through. We can work on it together.
Yeah. Okay. That would be better. Yeah.
But we can put like under research, under like utilities and something like that, and put it there.
So maybe, Ido, you explain why you say so. I think that you explained to us in the meeting before. So the idea is that every developer forks the complete repository locally, then adds his code, and then makes a pull request for the changes.
Yeah.
And that's what.
Yes. So the idea is that you can work on your own copy of KS360 repository, do whatever you want with it, and the moment you have a feature ready, you can create a pull request for that feature, and that pull request will be reviewed and will merge it or squash it into the main repository. So this way it allows us also to protect the main repository to make sure that it's always like compiling, always working, whatever, and it's not like chaotic.
Mm. And that's the reason why every developer shall first fork it locally, and then add his code, and then make another pull request. That would be the cleanest way to do it.
Exactly.
And this is also true for David. David, you have code on your GitHub repo as well. So I would like to ask you whether you can fork the Sky360 repo locally to your local computer, add your content there, your code there, and then make a pull request to be integrated to.
That sounds good. Yeah. I've got a kind of Jupyter script for the entropy stuff I was doing, auto exposure, Jupyter scripts for stuff I've done in the past, on cloud detection and all that sort of stuff. Do you want that in the research folder?
Yes, that also under Richard, probably under like utilities or something like that.
Yeah. Okay.
Yeah.
No problem. Yeah. Just to Jannik, I really like the Triangulation app. It's really cool. It's really helpful.
Thanks.
On the GitHub usage, ChatGPT is really good for coming up with codes.
It was super helpful, actually, because I don't know much about making apps with Python. So
cool.
I think ChatGPT probably 5x'd my speed on that. So easily.
Yeah, the commands for Git, it's actually really good for reminding. I use it all the time for reminding myself about commands for Git. So forking and then putting pull requests in and all that sort of stuff. So.
Okay. Yeah.
Recommend it.
Maybe I can try that too. Yeah.
Yeah, or you three.
But I'm still gonna ask Ido first.
Yeah. So maybe it's good if you three just meet the next days for half an hour or so.
Yeah.
Sounds good.
Yeah.
Okay. Yeah. So I'm available like Thursday and Friday this week. It's kind of hectic for me.
Oh, okay. Yeah, I'm. Maybe we have to postpone it because I'm traveling on Thursday and Friday. But
okay.
Yeah. The week after that is more. I have
more
time.
That's fine.
Yeah.
Great.
All right. So thanks, Jannik. Great work.
Yeah, welcome. Okay. Gonna stop sharing now?
Yes.
Okay.
Thank you. So, one little tiny thing I want to show you and discuss with you quite shortly is I share my screen if I'm allowed to. No, that one. So, and I need that one. So you see my screen?
Yes.
Okay, you see my screen. Okay. So what I want to say is, why can't I make this? Okay. You still see that? What the heck is going on here? So you see the adapter of the OSCAR cam?
Yes.
Okay.
Yes.
Okay. So what we did is we created a little vent duct, because this is the adapter, and here sits the camera, and the camera has an outgoing airflow, and we actually has two. One goes to the left, one goes to the right. So we use one airflow and we redirect it with this little vent duct into the dome. This part is already done. Oliver will now 3D print several parts, and we sent them to people in need, and especially those who can set their all-sky cam with the dome and best the whole enclosure outside, so that we get real life situations where we can test whether this is enough for reducing dew or not. So we will do it in Austria, but I would then ask you guys in your environment, in your weather situations, to also use that little guy here and test it outside. So this is one thing we should really do in various climate situations, whether that helps. So that's it.
Nice.
That's it. So that's basically it for today. We have holiday season. It's mid of July, and it is not much done on anyone's side in the last couple of days. So we thought we make it short today. If there is anything else, otherwise I stop recording now. If anything else, Lionel, for example, you want to have on record? Okay. You're muted, by the way, Lionel.
No, it's been a while since I could attend the meeting, but well, it's great seeing the progress on that triangulation thing. I wasn't aware of that. It's great stuff. And yeah, I'll take a look in GitHub in the coming days. I'm gonna have more time now. But yeah, great stuff, you guys. It's awesome.
Thank you. We recommend
It's
every
great to see things keep progressing when you're not.
So, by the way, we encourage every developer to go on GitHub and look for the changes that Ido and Fabio were doing the last couple of days, weeks, and to get yourself familiar with the new structure. But it's not fully done yet, as I heard, Ido, right?
Well, yeah, we are. I mean, we are working towards making it ready for like Aloha. So we are going to put more documentation in it. But if someone wants to contribute, they can go ahead and start and please, if you have questions, just write it on the issues, and we can answer there. So that will be easier.
And
Yeah.
I'm gonna take a look in GitHub, but just a quick question: does live mode work now with the QHY?
What do you mean live mode works now?
That you actually can access the QHY stream from ROS.
Yes, that's
Yeah,
already working.
so yeah, you can access the stream from ROS. We have some performance issues with it right now that Fabio is looking into. And again, all the integration with OpenMCT are actually open issues that we hope someone can pick up and help us on that. If not, we will get to that when we get to that.
So how many FPS is that actually?
Not much. Yeah. I don't know exactly. Fabio will be able to provide you that information.
I'll just try it out. Okay.
Yeah, but again, if we reduce the resolution, then you'll get a better performance. And this is kind of like the weird situation that we see and observe right now, and that Fabio is investigating it.
Amazing. Okay, can't wait to fetch the change and put the station up.
Okay,
Yeah,
cool.
yeah. I'll actually ask Fabio, maybe he can create a GitHub issue around this performance concern. So we can track that. Maybe it will help others that are experienced that with ROS2 as well. I'll ask him to do that. Because it's kind of hard even for me to know what he tried and what exactly the issue is. It's kind of...
So are we the only one in the world streaming from a QHY camera to ROS?
It's not even, it has anything to do with the Orange Pi. It's like, even if he uses his own kind of desktop, he still sees the issue.
I suppose that the issue is the QHY camera.
No.
No?
It's something with ROS2.
Ah, okay.
It's not the QHY camera. The QHY camera driver that we have with ROS2 is working. It's something, we are not sure.
Wow.
But it's not the QHY. It's not the QHY camera.
Okay.
Okay, well, it's been great. Have a good day, guys.
But bear in mind, right now what we have is everything for development. Okay, and the Aloha version will be for development. It won't be like really production ready. The next version will be. Okay, so we are setting everything up so you can have OpenMCT, the QHY, and everything works under ROS2 with development images, so it's easy to contribute. That's what Aloha is. Okay.
So also, guys.
So we are trying to standardize our development platform to begin. Okay, so it's working everywhere and everyone using the same thing, and it doesn't. And we'll have an image specifically for the Orange Pi5 if you want to develop directly on the compute. Okay.
Okay. So guys, if there's no more discussion that's necessary to be on record, I stop recording now, and we all wish our viewers a nice summer. We will be here next weekend, but not necessarily with the full content because people are on vacation and not everyone is contributing at the moment. So it will be shorter videos over the summertime. Okay, with this having said, hello, aloha.